Alright, in this video we'll be talking about analog inputs, more specifically analog potentiometers, which will be probably the most common sensor that is an analog input that you will be using on an FRC robot, at least right now. Generally speaking, analog inputs are quite a bit different than digital inputs, which is what we talked about in the last stage, where digital inputs are either on or off. Analog inputs are continuous. They encompass a range. On the robo-reel, I believe that range is 0 volts to 3.3 volts with a resolution of 10 bits. We won't get into that too much. That's more electrical than programming. Generally speaking, it's not that big of a deal for you to worry about, at least not where analog potentiometers are concerned. That being said, as I mentioned in the previous video, the next couple of subsequent videos will be based off the code in previous videos. So you'll notice that all of the code that was in the last video will also be here. So if you remember from the last video, we had created all of this stuff. Speed controllers for our drivetrain, speed controller groups for each independent side, a differential drive to control them together, an Xbox controller to control everything, and a bumper button to stop the robot doing autonomous should we bump into something. We've added two more things though. We have added an analog potentiometer. Now, to go over a little bit about what a potentiometer is, you can think of it sort of as the volume dial on the radio in your car. That's a pretty common use for a potentiometer. Basically, it is a small rotating knob that changes its resistance, which is a characteristic of an electrical system, in order to change the amount of voltage coming into another system. An analog potentiometer is useful for things like knowing the position of an arm or a wrist. So let's say you had to lift something for one of the competitions. If you wanted to know exactly where that arm was at any given time, you could use a potentiometer. This is as opposed to an encoder, which is not limited in range like a potentiometer is, but there are complications with using an encoder that require a fair bit more math in order to figure out where the arm is. So potentiometers tend to be a better solution. So the first thing that we create is an analog potentiometer object reference that we can use in order to get the actual angle from our potentiometer. Generally speaking, it's no more difficult than getting the value from a digital input. It's just rather than it being a true or false value, it will be something called a double value, which is basically just a decimal value with a lot of space for decimal points. The second variable that we've added here is called potentiometer range. Now, if you're looking at all of this extra stuff right here, these two things right here, static and final we won't talk about too much, but basically what it means is this is a constant. This value cannot change for the life of the program. You hard set it in your code to represent a value and it should never change. And what we set it to is 270. That value just representative of the number of degrees that the potentiometer that I have can rotate before it stops rotating. And if you try to rotate it any further, either in the opposite direction towards 0 or in the other direction towards 270, it will probably just break. In Robot Init, when we create our analog potentiometer, we actually have to provide three values. The first value is the analog input that the potentiometer is plugged into. Analog inputs are four sets of 3 pins on the bottom of the robo-reel, clearly marked, just like everything else, In this case, we just used 0 because it was the most convenient thing to plug the analog potentiometer in when I was building my robot. The next value that we provide is the total range of the potentiometer. In this case, it's the value of our potentiometer range variable, which is 270. The last value is useful for some things and sometimes not for others. It is the offset. What you can do is you can specify a custom offset to change the range of your potentiometer. So rather than the range being 0 to 270, you could use the offset to change it to be negative 135 to 135. Generally speaking, you can make do with just using the 0 to 270 range and just being smart about it. But some teams do like to adjust their offset for one reason or the other, and there are reasons to do it. But generally speaking, for the sake of simplicity, at least for this example, we're just going to stick with 0 so that the range is 0 to 270 degrees. As I mentioned in the last video, robot periodic is here. That's another method that runs roughly every 20 milliseconds on your robot whenever your robot is running. It's good for things like putting values onto the smart dashboard, which is basically just a little heads-up display that shows you different information that you put there. In the last video, we put bumper button pushed there to put the value of the bumper button. And in this video, we added another value called pot angle, standing for potentiometer angle, that gets, right here, the value of the potentiometer, basically just the angle of the potentiometer. Now, in autonomous periodic, we've changed a couple of things. So if you remember from the last video, the values for tank drive to get the robot to move forward, which is right here, all this right here, were static. They were 0.4 and 0.4, basically 40% speed. In this video, what we do is we use the potentiometer angle to create a value between 0 and 0.5. The reason why I say 0.5 is because I divide the whole value by 2. We'll talk about that in just a second. Keeps my robot from crashing into walls. Basically, what it says here is if the bumper button is pressed, then set each side of the drivetrain to whatever the potentiometer value is, 0 to 270, divided by 270, divided by 2. So basically what that does is it boils everything down to a value between 0 and 0.5. You're basically trying to find whatever percentage the potentiometer is turned by taking the potentiometer value and dividing it by the range, the total range, 270, and then dividing that value by 2 so that the range is crushed to only be from 0 to half of full speed. I do the half of full speed thing so that my robot doesn't crash into walls, as I mentioned in the previous video, because I don't know that my bumper button would survive the process if it crashed into it at a full 10 feet a second. That's what happens if the bumper button gets pushed. If the bumper button is not if the bumper button is, okay. That is what happens if the bumper button is not pushed. Blah. Otherwise, if the bumper button is pushed, then the robot is simply told to stop moving. Now, as I mentioned in the previous video, this isn't necessarily perfect. If the button somehow became unpushed again, the robot would start moving again. But basically what this does is it makes it so that I can walk alongside my robot, turn the potentiometer, and make it speed up or slow down. Generally speaking, I wouldn't recommend walking alongside a robot while it is moving. I would not recommend being in front of a robot while it is moving, like you probably saw in the last video where I was sort of in front of the robot to get it to stop. But for demonstration purposes and for the speeds of the robot that I'm using, it's generally harmless. And then, of course, down here we have our teleop periodic. That's not changed. I'm not going to go over that again. That being said, like I said in the last video, this is a very fast overview of analog potentiometer. There are other analog inputs that exist. In fact, other types of sensors often have analog outputs that you can use as analog inputs to your robot in order to take in information. Just one off the top of my head would be the MaxBotix proximity sensor. While using analog input may not necessarily be the most accurate way of getting information out of that sensor, that is one option. But generally speaking, a lot of what you'll see with analog input is something to do with a potentiometer or something. There is an analog pressure switch, which we talked about in the first video, the electronics video. I haven't seen too many teams using that, but there are other analog inputs out there other than potentiometers. It's just potentiometers lend themselves very nicely to demonstrations. So obviously, if you have any questions, please let me know. Email, Facebook, getting a hold of somebody else to get a hold of me, whatever works for you. If you have my phone number, you can text me, leave me a voicemail. As I mentioned in the last video, my gallbladder surgery is the 2 weeks before kickoff. So I'm trying to get everything done before then. But of course, if you leave me a message, I will get back to you when I am functionally sound. That being said, the next part of this video is going to go over just how the code works visually with my robot. And then I believe the next video that we have is encoders. So we will be talking about encoders and how they work.